Hey, what's up guys? My name is Cherno. Welcome back to my Game Engine series. So last time we took a look at instrumentation, and in fact we've kind of had this profiling series that we've been taking a look at. Check it out if you haven't already. It's really interesting stuff, even if you think that it's not necessary to take a look at that now or you're not interested in it at all. Believe me, you will be at some point, because there's going to come a point if your application, if anything you're building gets large enough where you're actually going to want to take a look at it and see what it is that's slowing it down and have more of like a holistic view of what your application is even doing. I want to take a break from that kind of stuff right now because, again, as I mentioned, it's not something that we necessarily need to actually be looking at right now. It's very important to have that system set up because it'll be really vital in the future, but we're not at the stage where we have to actually diagnose issues with performance in our engine whatsoever. What I do want to do instead is take a look at a few little cleanup things that we can do in preparation for taking kind of the next step with this engine, but also just because the last video that I actually made a game in 1 hour using Hazel. Definitely check out that video if you guys haven't, because it's really super interesting to take a look at what Hazel's kind of capable of. And also, this is the first time I have sat down and decided that, okay, I'm going to sit down, I'm going to make an entire game, start to finish, as quickly as possible using this engine. I know other people from the community have actually made little games, like I know someone made like the Game of Life or some kind of little test like that. It's all in kind of the Discord. If you guys are not part of the Discord, I'll leave a link in the description below. The Discord is just like a community where people talk about all sorts of things, including Hazel, and share things that they've made and suggestions and all of that stuff. It's a really cool community. Definitely check it out. But I sat down, I made a game, and I realized that, well, it's not like I didn't see this coming, but I realized that, okay, there's a lot of things that Hazel needs, and there's a lot of current things in Hazel that can be improved. I'm going to make a video pretty soon about actually taking a look at like that game that I made and dissecting it, and in that video I'll also probably make like some kind of list that just shows what I think we need to do with Hazel, major features, as well as kind of little adjustments that I think will kind of go a long way, as well as like, adding cross-platform support and all of these other kind of auxiliary things, I like to call them, because they're not central to core functionality. It's more like just across the board, making the end product, the game, a little bit more shippable and a little bit more polished, as well as the experience with Hazel a little bit better, basically. But anyway, check out that video. I'll have it linked over there. It's a really cool, fun video to check out. And today we're just going to take a look at some of the minor things that I want to make. These are directly things that I've said in that video where I'm like, hey, you know what? I have to change this, or I have to actually go into Hazel's code and modify Hazel's code to make it work. That's not good, because in that video I did have to actually go into the Hazel project and modify specifically that renderer 2D file and the actual default shader as well, because it just wasn't it wasn't doing what I needed it to do. So we definitely need to fix that stuff. But first, I want to give a huge thank you to all the patrons that made this series possible. Patreon.com/thecherno is the best place to help support this series and everything that I do here on YouTube. There's actually a behind the scenes video that I've just released this week on that other video that I made, so that stuff is available to patrons, as well as access to the development branch of Hazel and other kind of source projects that I work on. Definitely check that out, and huge thank you, of course, to everyone who supported this to make this possible. So let's dive in, take a look at a few different things and a few little issues, and we'll kind of just fix them up. Okay, so the first issue comes from us actually launching this. This is great, everything's fine here, but obviously this texture, the texture that we're looking at, that checkerboard texture, is not actually the texture that we're trying to render. If we look at the checkerboard texture, you can see that it's this big, right? It clearly does not have like a billion like cells, it's got 8 by 8 cells. And that's what the texture looks like. Whereas if we look at Hazel, it's tiling it a lot, which is fine. That was to demonstrate, I guess, tiling. But unfortunately, that code literally lives inside the shader. Here it is. It's this 10. It's us multiplying our texture coordinates by 10, meaning that now our quad is between 0 and 10 in both the X and Y texture coordinate instead of 0 and 1. And that's why we get that effect, because we're repeating our texture past its bounds. Now, this also has to do with the texture filtering settings. Well, not specifically the filtering settings, but the, I actually don't remember what they're called, so let's just take a look. The wrapping settings, right? So our wrap at the moment is hard-coded to be GL repeat. That's not the only wrap mode we have. There's also, GL clamp to edge. I think clamp and clamp to edge are the same. There's clamp to border and clamp to edge, but I think clamp is just clamp to edge. Anyway, In fact, maybe we can take a look here. No, clamp has its own ID. Anyway, clamp and clamp to edge. I'm not even sure if we can use clamp here, but basically if we were to change this to clamp to edge, for example, we'd get a very different effect from our shader, because now if the texture coordinates are past a certain amount, actually I'm just speaking rubbish, aren't I? This is if we're creating the texture using not a file. So let's just put that clamp to edge into the function that loads the texture from file. You can see we get something very different because it takes that last pixel and just repeats it instead of actually repeating the entire texture like we saw before, basically just like using a modulus operator and looping through those pixels. So this is something that needs to be taken in as parameters, as some kind of texture properties. And we are going to do that eventually, but we'll still leave this as a repeat for now because I think repeat's slightly more useful than clamp as just a default kind of mode. And then what we're actually going to do is go back into this shader and we're going to modify it to actually still have this property because we don't want to change the functionality. I don't want to get rid of this and then suddenly be faced with something like this where it's just like, this is not the result I want. And I also don't want to make a huge texture with a really kind of, I mean, that's going to be quite a high resolution texture. And it's completely unnecessary because here all I want to do is actually tile everything. So what I'm going to do is add a new uniform called, it's going to be like tiling factor or something like that. And then what this is going to be, I don't even know, like tile multiplier, tiling factor. I don't know what a good name for this is. I actually think that I will call it tiling factor. I kind of liked that. And then what this is going to be is just a uniform that we multiply with our texture coordinates like that. I don't know why I did m underscore. And then this is something that will enable us to, it'll just be set to 1 by default by our renderer 2D. And it's super easy to add these uniforms, by the way. You can see that what I'm doing here is basically, inside a draw quad, for example, when I'm drawing anything like that, if I just want to set that, I can easily just say, s data texture shader, set float, and then, u tiling factor, and then we'll just set that to 1 by default. And then that's kind of it, right? Really easy to have this done this way, which is cool. Set float doesn't exist, okay? Ignore me saying this was easy because this is Hazel and nothing apparently seems to be easy. But we'll just quickly add that in. We are going to eventually transition to uniform buffers and have more of an API agnostic way of doing things. That's definitely coming, but while that doesn't exist, I don't want to make the engine completely unusable, so I am going to add all of these kind of functions here, even though it kind of pains me to do so. So we'll add in the set float here, set it as pure virtual here in the base class, and then we will just implement it, and we'll basically copy everything from here, and this will be upload uniform float. Okay, that's done, right? So now going back to renderer 2D, which is over here, we can just set that float, and that tiling factor has been set. Now we need to remember to set that everywhere where we actually want the tiling factor, and obviously instead of setting it to 1, for example, if we're rendering a color, we could not care less what it is because it's not going to be a factor at all, because obviously what we do if we render a color is we bind the white texture, and that's a 1 by 1 texture, so tiling is not going to have any effect on that whatsoever. But for the other ones it does matter. So you could argue that there's no reason to set tiling factor, and I guess if you really wanted to be optimal here, then we wouldn't set this uniform at all. It's a waste of time. However, in reality, when we do the full uniform buffer upload, which is what we'll have to do for this stuff in the future, it's not going to matter if one float is one value or another. So I'll leave this in here as almost like a little guide to us telling us what uniforms we're using. And then, I promise you we won't see a performance difference if we remove this anyway. Okay, so we have these two parts, that's great. Let's test this out. The other problem though is that I want a tiling factor, right? We don't need to add this to this API. There's clearly not going to be a tiling factor for rendering colors. But if I do add something like a, float tiling factor equals 1.0f like that, just so it's a default parameter and everything's nice, it's still kind of making this a little bit congested, right? So we want to draw a quad, but suddenly we have a billion parameters. That's not something that I really want. We could have a lot of overloads where we just have kind of like what we have here with this vector 2, with this vec 2 and vec 3, right? So we're kind of splitting it up, making it support both, and that's really nice. But on the other hand, I don't want to have a billion draw quad functions. So what I sometimes like to do, and what I actually did in that video where I did make that game in an hour with the particle system specifically, is I made a function called particle properties or something like that. So a struct called particle properties, and then that had what, like 20 parameters, 10 parameters in it that you could control. And then what I did was I just passed that struct in. And that struct can just have default values and everything like that. It's got no runtime cost to have a struct instead of like a bunch of, just parameters, I guess, for a function. And then that way it's just one parameter. You pass in one parameter and that's it. Not only that, but that struct can be created by a class as like a member variable set up once, and then you can only change parts of it that you care about changing. So it's almost like a template, right? Not like a C++ template, but like an actual template. And you just kind of pass in that template. We're just modifying the areas that you want to make unique to that specific particle, such as its starting position, its emission position. And then you provide that struct to the actual, like, in that case, particle system, in this case, draw quad function, and it has all the data it needs anyway. So that's something that I will consider for the future. Probably not instead of this stuff, but just in addition to this stuff, because sometimes, like for example, I have this, let's just say I have a player character. I want to render it, right? It's always going to have a constant color or a constant texture. It's going to always have a constant tiling factor, a constant size. The thing that is variable is position. So why do I have to set all those properties every single time that I want to, call this draw quad function? It would be easier in that case to have like a quad properties or quad whatever, quad variables, quad settings, not settings, I had a different word, but anyway, quad properties, right? To have that kind of struct there that has everything filled out, and then we just change the part that we care about changing. Again, definitely a viable thing to do. I do that often, but I didn't do this here yet in this case. So now that we have the tiling factor, we can pass that in here instead. Now, if we launch this, we should see absolutely no difference. I wouldn't expect to see a difference at all because, we've added a default parameter and we've also set it to 1. In most cases, yeah, we don't have anything here at all. But if I do go into Sandbox 2D and when we actually draw our checkerboard texture, which we draw last here, what I can do is add a tiling factor of 10 as we had before. And that's basically saying tile that checkerboard texture 10 times over, right? Both horizontally and vertically. And then we kind of have our familiar result here. So that's the first step that I want to make. That's one of the first things in that video where I did make the game in an hour. I keep saying like that. If I say that video, you guys know what I'm talking about. But anyway, in that video, that was one of the first things that I did. I had to actually go into the texture shader and be like, why is my player texture being tiled 10 times over, right? Not something you want to do when you have an hour to make a game. Engine should just have that immediately like taken care of. So, but by adding this parameter, by adding this actual, I guess, parameter that we can modify when we actually draw a textured quad, we still have that ability to actually tile that texture without, completely changing our shader or having to do something custom in the client-side rendering code. Okay, onwards. So the other thing that was really important and kind of a big deal was the fact that I could not rotate my ship at all, my player ship. I had to also go into the renderer 2D and actually add a rotation, so we don't have that. So we have, it seems a good place to add it between position, size, and then rotation, right? So float rotation, and then we should support rotation for everything. I can't make it a default parameter because it's before like this stuff, which makes me question again, whether or not we want to actually have this anywhere whatsoever. This is totally something that you can do, but you should also probably, you could also take into consideration the fact that a rotated quad might be something completely different for you and your renderer than something that is like axis aligned, right? And because of that, instead of adding a float rotation here, another viable thing to do is add a completely different function that's called something like draw rotated quad, right? Instead of just again adding an overload. So draw rotated quad, for example, is specifically saying that I want this quad to be rotated. That means I'm ready to accept an additional matrix multiplication, I guess, and construction, right? That's like an extra, because it is an extra cost to say that, okay, I'm rotating this, right? Like we have our transform here, and you can see the transform, which I definitely will represent like this from now on so that we can see everything. The transform at the moment is just simply a translation and a scale, but what we're saying, if we want a rotation, we're saying we're going to add in a GLM rotate. We're constructing this matrix here, this is a rotation matrix, and then we're having to multiply that with like the translation and the scale, which is it's an extra matrix multiply, and it's an extra matrix generation. And a rotation matrix is not easy to generate. I mean, look at this, right? We have quite a lot of maths going on here, including cosine and sine. So we've got trigonometry, we've got a bunch of multiplications and, you know, additions, subtractions. There's quite a lot of stuff to construct here. It's not as simple as, say, a projection matrix or a, you know, a translation matrix, which is, you know, dead simple. I mean, or a scale matrix. Let's take a look at this. So translate, that's the whole translation matrix. And scale, you know, this is the whole scale matrix. Nothing basically to do whatsoever. But a rotation is like a big deal, as you can see. It might not be something you want to incur every time you render an axis-aligned quad. So because of that, what we're actually going to do is separate it out that way and make this like specifically, that's it, draw a rotated quad, which will have like a rotation. Because I don't think it's that often that we necessarily want rotated quads. You know, like in a lot of scenarios, you would never really rotate something. Like your animation within that quad might have certain rotations associated with it, but usually, I don't want to say usually just because I can't think of everything you could possibly make with Hazel right now while I'm sitting here making this video. But as far as I can tell, there's usually quite, there's a lot of scenarios in which you don't care about rotation whatsoever. It's just not something you want ever. And for that, I also want to provide like a fast code path for that specific scenario, since it is quite a frequent thing to want. Okay, so this is going to be the color version of that. And then I also want to have a non-color, so a texture version of that, which we will also have a tiling factor for that, because we might as well. Okay, so now we have this specifically here. Again, this is like a Vec2 version. Whether or not we want a Vec3 version is again, kind of up to you, I guess. I guess I will do that just for completion. You can see that we, you know, designing like an API, and this, by the way, should have been a copy of this. Designing an API that can handle anything is quite a lot of work, specifically with just, you know, minor changes, I guess, here and there. Let's go ahead and try and implement all of these methods at once. But, you know, the payoff obviously is the fact that, you know, you can kind of basically give it any kind of data you want. The other thing that is difficult though with this is to make sure that you're not actually accidentally introducing errors, because it's very easy to make this API so extensive that people aren't going to know what to do, and sometimes they might actually use the wrong thing, and that can be obviously quite dangerous. So that's just something to consider. Okay, so I'm filling these things in. This is the texture and tiling factor version. Especially if you don't have like a testing, like a sandbox or some kind of unit test that actually tests all of these functions, make sure you haven't accidentally forgotten something or you've done it like incorrectly. So yeah, it can definitely kind of end up being rather hard to do. Okay, so draw quad. Again, I'll copy this, and so what this is going to have is, this is the point where we don't care about the tiling factor. So I probably should have copied the other one. Let's put this into the textured version. This is the untextured version, just the color version. So we'll grab that and paste that into here. So tiling factor, we'll leave it 1 here. We're binding our white texture, and then I am going to just copy this and paste it. And then this is going to become our GLM rotate. And then we will rotate, this is a 2D renderer, so we can just rotate in the Z axis, and then, so I'll jam in, I think it's fair to say that it should already be in radians at this point. We don't want to incur that cost always in the 2D renderer of having to convert between radians and not, especially if someone's willing, if someone wants to do their rotation in radians for whatever reason, maybe it's coming from a camera or it's already in radians, obviously you'd have to convert back to degrees and to pass it into this function, which will then convert into radians. It's just a waste of everyone's time. So we'll have it in, assuming the rotation is already in radians basically, which you could annotate as part of the comment or as part of the actual variable name, but I'm not going to bother doing that because I think that should be obvious. Okay, so there we go. I think that's it. Really all we've done is we've added a rotation. I think that should be okay. Let's test this out, obviously. What I'll do is let's just try and rotate this checkerboard texture. So we'll draw a rotated quad. And then after the size, I'll just say GLM radians, and we'll just rotate it 45 degrees. That should be pretty easy to actually see. So let's take a look at that. Okay, cool, clearly at a 45-degree angle here, looking pretty good. And then I guess we'll try a colored quad as well that we'll rotate. So maybe let's take the red one, which is this one, and let's just try and rotate that negative 45 degrees. There we go. So that should be now rotated the other way. And I'm saying the other way, but since there's no texture on it, it doesn't matter if we rotate it negative 45 degrees or positive 45 degrees. Okay, so we're pretty much in line here. Cool, looking good. So we can now do rotation and rotated quads, which is nice. I might leave this red quad rotated, but I will maybe reset this to just be draw quad. So I quite like this API of like explicitly having to write whether or not something is rotated. I think that's pretty good because it just, forces you to use the right function if you don't want rotation and all of that stuff. Just because it is, like, we know it's more expensive to do a rotated quad, even though it's not that much more expensive. So yeah, just really makes you think. And finally, the last thing that I want to address is this kind of hue shift effect that I had to do for that game in that video, and that was to do with us being able to actually multiply a color to tint our texture. Now, to do that, we need to actually, we've already got that set up in the shader, we just have no API exposing it. So we really need to add something called a tint color that will actually be able to tint everything. Again, if you're just drawing like a simple like non-textured quad or anything, that is just the color of the quad. It's easy to do it. But if it's specifically something that is textured, like our checkerboard background, that needs to actually have an API exposed to tint it with a certain color. So let's go ahead and do that. Again, we come to the kind of the problem here of we have so much of these functions and we've already got default parameters. Do we just add another default parameter? Do we make like draw tinted quad? What are we going to actually do? So I don't think there's a correct solution for this. I mean, we've got a tiling factor for a texture, which you could also argue should be maybe texture properties, which you can also pass in here. And then maybe tint should also be a texture property. What I'm going to do for now though is literally just add it as a kind of parameter maybe that we have at the end. We've decided to add tiling factor as, a quad that's not tiled. Maybe this was something that we should have added as like a draw tiled quad and then a draw tinted quad. Instead of doing that, we just had draw quad with texture and a tint color. Again, whether or not we want to kind of do anything like that, it's hard to decide. And so right now I'll probably choose just one of these possibilities, and then as someone makes a game, or as I make a game, or as I just, time passes and I realize that actually it probably would have been better to do it this way, I'll probably change it. So just being honest with you guys, I'm not going to sit here and say that, okay, this is the final Hazel API. This is clearly in development. We'll probably change a lot of these things. For now, I'm just going to chuck it in the end of draw quad just so that we at least support that specific code path. So at the end of draw quad, I'll just add in a const glm vec4 tint color, and then we'll set this equal to glm vec4 1.0f. Okay, so we have it default being 1 here. And then I'll grab this and I'll chuck it into the, and we have to add this for rotated quads as well, by the way, so maybe I'll do that now. We'll just grab this and add that here, because this has to be available for all textured quads. So draw rotated quad, that's the non-textured version. That here is the textured version. So we'll just get rid of that comment and put it in here as a tint color, which is what U color will be. So tint color is becoming that. And then over here as well, we'll add this in. So tiling factor, at the end of that, we just add in a tint color. Oh, we have to remember to add it into the other spot here, by the way. Tint color. Otherwise we can forget. Okay, and then over here, instead of 1.0, we add in our tint color. Okay, cool. So to test that out, back in Sandbox 2D, all we need to do is for our draw quad here, we'll just try and tint that a certain color, maybe like a kind of, and remember anything closer to 1 is gonna, we'll tint it kind of red. Anything closer to 1 means no change, right? So this isn't like it's being added in as a tint, it's really just being subtracted here in a way. So like if we leave the red channel at 1, but then we set the green and blue channels to 0.9, then we're actually subtracting green and blue, and then we're kind of keeping red at the same amount. So it's almost like we're adding red, but really we're subtracting the other channels. So let's take a look at that, and then we'll try the rotated version, I guess, as well, just to make sure. Okay, so we can see we have an ever so slight red tint here. And then again, I'll just change this to draw rotator quad. I'll add in some kind of rotation just to make it super obvious. We'll try maybe 90 degrees, which should be no rotation. Maybe we'll do something like 80 degrees. So it's quite slight. And then that should also be tinted red, as you would expect. And it is. Okay, cool. So there we go. That's kind of the tinting in effect, which was important for the game because I needed to have kind of a hue shift effect, and I had to draw a triangle that was like a texture instead of an actual triangle, because Hazel can't draw triangles, but also because I needed to have like a glow effect, which we can't do without post-processing anyway. Alright, I hope you guys enjoyed this video. If you did, please hit that like button. Don't forget to help support the series and this channel on Patreon, because your support is what makes stuff possible, and I'm really happy to say that I'm able to do this because of the lovely people who do help support this, so thank you so much for that. Next time, I think what we'll do before next time probably is I will make that kind of looking back video, a retrospective kind of debrief video of taking a look at that game that I did make in an hour, and then we'll kind of make a list of what we need to do. And I think the first kind of step to do specifically in Hazel is going to be to try and add in all those engine features perhaps to make that game a lot easier to make. It's really good to kind of set a goal and then work towards it, which is kind of how I like to work and how I think we should progress here. Obviously, I want to continue on with 2D rendering and adding stuff like batch rendering, font rendering, post-processing, even all of that stuff. But again, with having that kind of game that I did make, which was like a Flappy Bird clone, with having that as like our end goal almost for a 2D game. I know it's a very simple 2D game. It's just made like in an hour, so obviously it's simple. But having that as kind of like an end goal, and then being able to add in all the engine features to support a more Unity-like approach, I guess, to making that game is kind of what we're aiming for right now. And then I'll probably eventually have like a planning, triaging kind of goal-setting episode as well, so that we can clearly define what we're going to do next year. Anyway, I hope you guys enjoyed this video, and I will see you next time. Goodbye.